Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to take a look at a word problem that can be solved with a system of two linear equations in two unknowns. Problem 6 says a youth baseball manager bought 4 baseball bats and 12 baseball gloves for $580. The manager bought 3 more bats and 5 more gloves for $275. How much does each bat and glove cost? And we actually have enough information to solve this. I'm going to use the variable B for bats and G for gloves. The first equation comes from that first sentence. It said that 4 bats plus 12 gloves equals $580. By the way, if you like using x and y, you could write 4x plus 12y equals 580. But when I get to the end of this problem and I have b equals $37.50, I know that b stands for bat, and it helps me to remember which variable goes with which quantity. But it doesn't matter what, pick your favorite letters, pick your initials, it doesn't matter. But I think picking the letter that goes with the unknown quantity makes a lot of sense. The second equation comes from the second sentence. The manager bought 3 more bats and 5 more gloves for $275. Now I have a system of equations with two unknowns. I can solve this using either substitution or elimination. And I look at this problem and I don't have a term with B or a term with G that is set up to solve pretty quickly. Although I might be able to solve the first equation for B without any fractions, but if I don't see a plain B or a plain G, meaning B or negative B, G or negative G, I think the best move is to jump right to the elimination method. Notice I don't have a positive coefficient and a negative coefficient for one of the variables, so that doesn't impact my approach. 3 doesn't divide into 4 evenly, 5 doesn't divide into 12 evenly, so I know I have to multiply both equations, but I would rather try to eliminate the variable whose coefficients are smaller. When I look at 4b and 3b, I know that those both go into 12, so if I make one of them into 12b and one into negative 12b, I can solve this equation. I'm going to multiply the top equation by 3. 12b plus 36g equals 1,740. And basically this is saying if the manager bought 3 sets of 4 bats and 12 gloves, it would have cost $1,740. For the other equation, I'm going to multiply by negative 4 because negative 4 times 3b is going to give me negative 12b. And when I add these equations together, that adds to be 0, eliminating one variable, leaving only one. Negative 4 times 5g is negative 20g equals negative 4 times 275 is negative 1,100. Add the two equations together. 16g equals 640. Divide by 16, g equals 40. So right now I know that each glove, G for glove, costs $40. To find the cost for a bat, I'm going to go back to one of the two original equations. I'll just pick the top one. 4b plus 12 times 40 for G equals 580. 12 times 40 is 480, so I can subtract that from both sides. And I get 4b equals 100. Divide through by 4, and I get b equals 25. So now I know that each bat costs $25. I can check the second purchase with these two values to make sure that I have this right. 3 bats at $25 each, plus 5 more gloves at $40 each. That's equal to 75 plus 200, and together that totals to be $275, which is what it says. So each glove costs $40, each bat $25. Now I mentioned that you may have been able to solve that first equation for B in terms of everything else and then use substitution. What I want you to think about here, 4B plus 12G equals 580. Can I divide the 4 out of every term and have only integers, no fractions? And so I can try that. I know 4 goes into 12. 4 also divides into 580 evenly. So this would have become B plus 3G equals 145, or B equals negative 3G plus 145. Now I could have substituted that into another equation. So it was possible to do it that way. I just think that unless there's a clean, plain variable term, jumping to elimination first is a good move in the long run. Let's try one more problem. It says the average salary of a college's president and vice president is $240,000. That means if we add up their two salaries and divide by 2, that's going to equal $240,000. It says the president's salary is $30,000 more than twice the vice president's salary. Find each salary. So for variables, I'm going to use P for president and V for vice president. And I know that their average salary is $240,000. So that means if I take the president's salary, add the vice president's salary, divide that by 2, I get $240,000. Now that looks a little different than the equations that we've been using, but if I multiply both sides of the equation by 2, I get P plus V equals 480,000. And that does look like an equation that we've used. When I see that equation, the first thing that sparks in my mind is I can solve this with substitution if I want to, because I can get P by itself or I can get V by itself pretty easily. The second equation comes from here. It says the president's salary, that's P, is, that's my equal sign, P equals 30,000 more than tells me to add 30,000 to something. 30,000 more than what? Twice the vice president's salary. This is perfect for substitution because I already have P isolated. P equals 2V plus 30,000. P is the same as 2V plus 30,000. And so I can take this and substitute it for P in that equation. Let's do that. So I'm going to replace P by 2V plus 30,000 plus the V that was already there equals 480,000. I've got some like terms to combine. I also have 30,000 that I can subtract to the other side. And that leaves me with 3V equals 450,000. Divide by 3 on both sides of the equation. V equals 150,000. So I know that the vice president's salary is $150,000. To get the president's salary, I'm going to go back to the equation I used to make the substitution. The president's salary is 2 times that 150,000 plus 30,000. And when you do the math on that, you'll get 330,000. Not bad. So if I want to check this, I can come back to this equation, P plus V equals 480,000. But what if I've made a mistake getting to that point? I can go to the one on the left, which is the one about the average. Is the average of these two salaries $240,000? Well, if I take the president's salary and add the vice president's salary, and I divide by 2 to get their average, that's a total of 480,000 divided by 2, which is $240,000 as asked for. So we can finish this up by saying the president's salary is $330,000 and the vice president's salary is $150,000. All right, a couple of examples, one that we solved with elimination, one that we solved with substitution. I know that a lot of students like to pick one method and use it for everything. But if you do that, you're making some of the problems harder than they need to be. Try to be flexible. There are some systems that will be set up better for elimination, but there will be some that will be better for substitution. And if you can only do one of those two types, you're going to make a lot of your work a lot harder. So try to be flexible with your approaches.